Here we are at the end of Statistics Mechanics Year 1, Chapter 9, looking at the challenge question on page 155. A ball is projected upwards, with a speed of 10 meters a second. 10 meters a second. From a point X, which is 50 meters above the ground. Point X, which is 50 meters. Above the ground, t seconds after the first ball is projected upwards, a second ball is projected upwards from X. Initially, the second ball is at rest. The ball collides 25 meters above the ground. Say that again. Above the ground, t seconds after the first ball is projected upwards, a second ball is dropped from X. So we've got a ball that is dropped from X at t after t equals t. Brilliant. Initially, the second ball is at rest. The balls collide at 25 meters above the ground. Find the value of t. So this orange ball has come down and it has then hit there. Find the value of t, how long it was until that got dropped, so that once it gets hit from there. So at this point here, I know I was doing 10 meters a second going downwards. Gravity is obviously doing its thing at 9.8. We're going to have some interesting signs going on here. First things first, let's do suvat for the second ball. So suvat for the second ball, its distance is 25 meters. Its initial speed we don't know. Its final speed we don't know. Its initial speed we do know, it was 0. Acceleration is 9.8 and its time we don't know. But we can find that out. So let's find out v and also t for both of them. So let's do the no t equation. So v squared equals u squared plus 2as. So final velocity, I don't think I need this one particularly, but anyway, v squared equals 0 squared plus 2 times 9.8 times 25. So v squared is equal to 2 times 9.8 times 25, 490. 490, so v is equal to 22.135. Let's work out how long that is. Because that's going to be a factor here. We need to know the one which has no v in it, please. So we will use s equals ut plus a half at squared. So s equals ut plus a half at squared. So 25 is equal to 0t plus a half times 9.8 times t squared. So 25 divided by a half divided by 9.8. Gives us 5.10. is equal to t squared. Okay. And then the square root of that is 2.258. Okay, 2.258. So we know this bit here takes 2.258 to happen. Okay, so at the point that this goes up 10 meters a second and back down again, okay, how long does it take for this? So for this first section, let's make it green. Let's do suvat on that. So the distance, I don't know. The initial speed was 10. The final speed was 0. The acceleration in this case, it's getting slower, is 9.8. And the time, I don't know, but I do want to know. Okay, so the time from here to there is going to be the equation with no s in it, v equals u plus at. So 0 equals 10 plus minus 9.8 t. Okay, so 10 divided by 9.8 basically gives us 1.02 seconds is equal to t. So it takes 1.020 seconds to get there, which means it takes 1.020 seconds to get down to here as well. Okay, so we're back here, so that's been doubled and we've got to there. And then as we continue down at this, how long will it take it to go from what would be the blue arrow, which would be the first ball falling here? Okay, so let's just do suvat on that one. Okay, the distance is 25, the initial speed was 10, the final, I don't know, the acceleration is 9.8, and the time, I don't know, but it's the time that I'm looking for. So, what don't I have? Final velocity. So let's use s equals ut plus a half at squared. And so we've done the 25 meters in 10 times 10t plus a half times 9.8 t squared. So we end up with 0 equals 9.8 halved is of course 4.9. So 4.9 t squared plus 10t minus 25, and that gives us t equal to quadratic. Use the quadratic solver on the calculator. Okay, polynomial 2, 4.9, 10 and minus 25 gives us a t of 1.458 and a t of minus 3.49. Let's disregard that one. Because negative time is a problem. So 1.458. So we've got the 1.02, the 1.458. Okay, so altogether the first ball has travelled 1.458 plus the 1.020, 020, but it did that one twice, 020. Okay, and so as we take that and add it all up, 1.458 plus 1.020 times 2, we end up with 3.498. So this has been a total of 3.498. The other ball took, was it the red arrow? It took a time of 2.258. If you remember just there, 2.258, it was this calculation here. Okay, so the red ball took 2.258 to get to the same point, and so the difference in those two times minus 2.258 gives me 1.24, and that must be how long you have to wait before you drop that red ball, which means 1.24 seconds is big T.